In this question, we're told that it's known that in a certain town, 30% of the people own an app phone. A researcher asks people at random whether or not they own an app phone. The random variable x represents the number of people asked up to and including the first person who owns an app phone. And we've been asked to determine some probabilities. First, let's try and decide what distribution we're working with. We're told that the random variable x represents the number of people up to and including the first person who owns an app phone. The first person, that would be the first person to successfully answer I have an app phone. That means we're working with the geometric distribution, a distribution that measures how many trials until the first success. So let's just state the distribution. X follows a geometric of 0.3. Our first probability is to find the probability that x equals 4, that it took 4 trials for the first success. That means we had 3 failures and then 1 success. 0.7 to the power of 3 times 0.3, and that gives us 0.1029. In part B, we're asked to find the probability that x is greater than 4, the probability that we needed more than 4 people to be asked before we got our first success. Well, straight away you know that we want to write this with greater than or equal to, so we have a number that we are actually interested in. So the probability that x is greater than or equal to 5. If we know that we needed 5 attempts or more, then we know we definitely have had 4 failures in a row. For the first 4 attempts, they were failures. This is going to be q to the power of 4. 0.7 to the power of 4, well, that gets us 0.2401. And in part C, the probability that x is less than 6. Once again, rewriting with a value we're actually interested in, so less than or equal to 5. If we got our first success in less than or equal to 5 attempts, one thing we know definitely didn't happen is that we didn't have 5 failures in a row. It was impossible. All other outcomes would need 5 failures in a row and then something else happens. We did not have those 5 failures. That'll be 1 minus q to the power of 5. It's 1 minus 0.7 to the power of 5. And that gives us 0.8319.